So operons, as you probably have heard, are a form of gene regulation in prokaryotic organisms. What does that mean? Operons can determine what genes are switched on or switched off. So the expression of the genes, or whether or not they actually make the protein they were meant to make, is determined by operons. And this is only a mechanism in prokaryotic organisms, not in eukaryotic organisms. A classic example is the lac operon in E. coli bacteria, and this helps break down lactose. So the lac operon is an inducible operon. Like any operon, it includes a promoter, which is where the RNA polymerase, the enzyme used to transcribe, binds to the mRNA. And then there's the operator, which we'll get to more in a minute. And then there's the gene of interest. The gene of interest is LAC-Z, LAC-Y, LAC-A in this case, and this is basically what you want to transcribe into protein. So as you can see here, in an inducible operon, such as the lac operon, the repressor is normally bound to the operator. So the repressor is made by a regulatory gene somewhere else in the genome. This regulatory gene is transcribed into mRNA and makes this repressor protein. This repressor fits into the operator perfectly, and it prevents the RNA polymerase from going and doing its job, transcribing that gene of interest. And this is in normal conditions where there's not a lot of substrate. But if we have a lot of substrate, one of these substrate molecules can bind to the repressor enzyme. And this causes the repressor to change shape. As you can see, changing the shape over here makes it a lot harder to fit into the operator. And therefore, the RNA polymerase is no longer inhibited by this repressor. So it can go and do its job and transcribe the LAC-Z, the LAC-Y, the LAC-A into mRNA, and it'll make enzymes that break down lactose. These enzymes will then reduce the amount of substrate that we have. And as we reduce it, eventually the substrate that was bound to the repressor before is going to come off. And when it comes off, the RNA polymerase can no longer get to the gene of interest and transcribe it, stopping transcription and translation, and our production of enzymes that break down lactose stop. And that's how inducible operons work.